This conference will now be recorded.
Okay, so today, today we are going to start with the supervised machine learning. You already know, I think you all know about that three types in machine learning: in supervised learning, unsupervised learning, and reinforcement learning, and semi-supervised learning. Now we are going to see only the supervised learning. So what is supervised learning? In supervised learning is where you have input variables and output variables, and you use an learning algorithm the mapping from input to output. So that's why y equal f of x. Here x is an input variable. We have one the mapping function. That mapping function find take the input as a x and find that y. Okay, Mm, so here there are two types in supervised learning. One is the classification and regression. So what is the classification? In classification, we classify for example, the red or blue. The person contains a disease or not, like that. And the regression, you find that predict the future values. Okay, so now in supervised learning, we are going to see the one example, example in classification. In classification, we are going to work in one algorithm. So k nearest neighbor algorithm. So now we see that how k nearest neighbor is working, and what is the max behind the k nearest neighbor, and what library we are going to use to implement k nearest neighbor. So now we start with the max begin the k nearest neighbor. Okay, okay. In geometry, in two-dimensional space, we have 2 points. In these 2 points, if we find the distance between the 2 points, we can use the equilibrium distance formula. So we take the example. This is the 1 point. So this is the x-axis. This is the y-axis. This is the in two dimension. In this two dimension, we take that 2 points. We see this is the p and this is the q. So the p1 q1. So p2 q2. We want to find the distance between the two variable. Sorry, 2 points. So we to find the distance between the 2 points. We use this equilibrium distance formula. So q1 minus p1 whole square plus q2 minus p2 whole square. So using this formula, we can find the distance between 2 points. Okay, why do we need like this calculation here? So if we take the k nearest neighbor is going to work based on finding the distance between points. Okay, so that's why now we are going to use the equilibrium distance formula to find the distance between 2 points. Okay, so we keep this formula as it is, and now we are going to see one another example. Now, we have our own data. That is, the data is the based on the weight and height. We are going to classify the person is a male or female. So here in the x-axis I have the weight, the y-axis I have height. So based on I here I said that he is the person is a female or male. Just I put it the all I put the all the data in and two-dimensional space. Here is put it. The green color represent the female, the red color represent the male. Okay, so now I have the new measurement, right? The new measurement here, this color represents the new measurement, but I don't know this measurement represents female or male. So I don't know. So I want to classify is this measurement is a male or female. I need to classify. That's why I'm going to find the distance from this point to all fine. I'm going to find the distance from this point to all fine using the distance calculation formula. Just I calculate that. After calculating, I'm here. I just choose that k value. K equal 3. Just I choose the k value. K equal to 3. You can choose that k equal to 2, 3, 4. Anything you can choose. But finally you should choose the optimized k value. But the how to choose the k value we will see final step. But how now we are going to see how the k nearest neighbor is working. That is why just for example just we take the k equal to 3. The k equal to 3 using this one we are going to we are going to classify. So now before I choose the k value, I already found the distance between from this point to all point. After I choose the k value equal to 3, just it's going to take the nearest 3 point to this one. Only take the nearest 3 point here. If I take the k equal to 4, only consider the 4 nearest point for this one. If I consider the k equal to 2, I take the 2 nearest point this one. So now finally I just choose that k equal to 3. That's why just I consider the 3 points nearest to this one. See here 1, 2, 3. Here is the one red. So in this 3 point, which category is the most majority category? If you see here, I'm going to choose the, this is the red. Red is the two, here there is two red, one green. That's why majority category is red. That's why this I'm going to classify. This is the male. So finally we say that the uh, new measurement represent the we classify the new measurement as a male. Like this, the k nearest neighbor is working. So this is one example. We see the another one example. I'm going to show that another example with the calculation. Now just I explain. Okay, I'll show the calculation. Okay, here. So I have here another one example. Here we take the one example. This is the one data. This data is we collect the data. The special paper dish is good or not based on the paper aesthetic durability and the strength. Based on the special paper dish is good or not, we are going to classify based on the acid durability and strength. That's why here we have the four measurement. So one row represent one paper. In this one paper, the what is the acid durability, what is the strength. Like this, we have the four measurement. So two input. So one variable. This is the one variable. This is the another one variable. So two input, one output. One output is here. So the output is category. We are going to classify. This paper is good or bad. We are going to classify. So now based on this, using this one, k nearest neighbor. Using k nearest neighbor, we are going to classify for new information. If we have a new information, that the information is means if we have the acid durability and strength for new disk paper. That new disk paper is good or bad. We are going to classify the k nearest neighbor. So okay, now I have the acid durability 3. I have new measurement. That is acid durability x1 equal. See, I'm going to new information. Here I have a new information. X1 equal 3 and so x2 is equal 7. The acid durability 3 and strength is 7. This is a new information. This name, based on this new information, I'm going to say this is good or not. I want to classify. This is a good disk paper or bad disk paper. I need to classify. So that's why I'm going to find the distance between from this point to all the point. So that's why if you see here, distance is calculated 7 minus 3 whole square plus 7 minus 3. This is the x1, right? So this is x1, this is x1, this is x2. So yeah, this one, so 7 minus 3, 7 minus 7. That's why it's calculated distance. And this way, so distance is from this point to all the point is distance is calculated here. So 16, 25, 9, 30. So next we are going to choose that. Next we need to choose the k value. Just to choose the k value is the 3. Okay. After that, I just to choose the k value 3. After choosing, which is the nearest point, which is the minimum distance for this one, so this is the minimum. That's why next minimum this one, next minimum this one, next is this one. So the minimum distance, so longest distance, so we just classify, just we ranked it. So minimum distance to maximum distance. After that, we are going to say we need to only three. We need only three distance. That's why just we have three. We take the three distance. That's why what is that? This one is yes. This one yes. This one yes. So only we are consider. We are going to consider only three. That's why yes, yes, yes. We have one here, right? In this yes, what is that? The this one we are going to say we have one SS. What is we need to finalize majority. We need to find the majority, right? If you majority here, see the good, the bad. So what is the good? So in the, if we take the only three, for these three, what is the bad? What is good? So in this, what is the majority? Majority three. So majority is good. The good is two, one bad, two good. So majority good. That's why finally we classify this measurement is the this measurement is a good disk paper. The disk paper is good. Using this one, finally we classify. So now we have seen only two examples. Now we are going to implement using Python. The same concept. Yeah, tell me. Government. Just
This conference will now be recorded.
okay. Now, so far we have seen only the theory of k nearest neighbor. Now we are going to implement the k nearest neighbor using Python. So, okay. Here I have another example. In this example, I'm used the iris flower. Based on the iris flower information, the flower information, the sepal length, sepal width, pedal length, pedal width. Using the four variables, I am going to classify this as sedosa, versicolor, or virginica. So I will show you that what is the flower here. See, I will show that what flower information we have. Let's see this one. This flower information. We have collected this flower. We have collected the length, sepal width, petal length of this flower. Here we have the flower information. So using this flower information, we are going to classify this is a sedosa or vesicular virginica. We are going to classify the three flower. So now I just here see just I imported the dependency libraries, and then I have import the flower files, and then here I list out the column names, and then I'm going to read the this file, the flower file. Just here the flower file is the just in text format, and here I just use the read underscore csv method to read and sorry load and read the this text file. After loading, just I am going to view the data set. See, this is loaded. So the defaultly this head method will show only uh, 5 rows. If you want to see, if you want to see the 10 rows, you can mention 10 rows. So that's why how many rows you want, you can mention here. Okay, now I'm going to check that the shape of this data set. See here this data set, so 152 5. What does mean? This is a we have the 150 flower information which represent the row and the 5 columns. So if you see, the one row represent the one flower information, one column represent one variable information. So that's why we have four input variables, one target variables. The target variable here is a class. Okay, now just we are going to describe here in this when we implement the k nearest neighbor, we are not going to see that the statistics point. We don't see the any statistics point. We don't see here. Just we are just to look at that little bit of the statistics, and then we move to implement the k nearest neighbor. So just here I just used the description method. Using this description method, we can see what is the count and the mean, standard deviation, minimum value, what is the 25th percentile, 15th percentile, 70th percentile. This is a quick description about this data set. So next we going to move to how many incidents for one category. See, just I applied dataset dot group by, just I passed that category, sorry, class name, and then dot the size. If we call this one, just we can how many incidents for one class we can see. This is Sedosa. We have the 50 flower information for Sedosa, and then 50 flower information vesicular, and the 50 flower information for Virginica. So we have finally the 150 flower information. Okay, now we will see that how data is distributed. So if you see, just I have used the box physical plot, data set dot plot. So just I mentioned that we need to display the data set using in the box plot. That's why kind equal to box subplots. We need four subplots. That's why we need that subplots true. Layout is 2 into 2. Share x-axis and y-axis we need to share. That's why, but here we don't share that any x-axis, y-axis. But that's why we are given that share x equal false, share y equal to true or false. See, if you see, just I mentioned that share y equal to true. Given, you will see what is the changes here. See, the x-axis and is sad. Here there is no measurement here, right? If you see that, but also for this measurement, our chart is going to smooth. So that's why if we hear the false, see the measurement is displayed here. That's why the share x, you can share that x is labeled to all the sublet, all sublet, and share y represent the y-axis labels. You can share. Okay, now we are going to we need to implement the k-nearest neighbor, and before we implement we need to split our data set, the exact input and the output. Here I just split the input only. So x equal data set I location. The I location, using this one we can split that only input columns to x, and the what y is the means here is the target variable. Target variable is a class. Before you pass the target variable to algorithm, you need to convert the categorical to numeric. That's why I have used label encoder. Using this label, just I imported label encoder from scikit-learn, and then just I created a new instance for label encoder. I just use this just here I mentioned that the the target output, and then I this instance is fit on this data. So new dot fit underscore transform for this data. So what is the meaning of here is the fit underscore transform? Fit first your fit your new instance on data, and then fitting is just checking the all the categorical variable. After that it's going to transform categorical to numeric. So after transform you will see that what is the result. You will see here, see that all Sadasa is going to is the name is given as the 0, Vexicalas name is given as 1, and the Virginica name is going to given the 2. So the categorical, all the values categorical to numeric value is converted here. Now our data is ready, right? So now we need to split our data set. So two part. One part is training part, and second part is testing part. You see, you have a so that you have a, just to you have this is the data set. Take this one called data set. There are a lot of columns here, and there are a lot of there are a lot of columns. This is going to be a target, right? So we need to split this data set. One part is for training, another part for testing. So you can split out this data. So two part. This I'm going to split like this. Just I mentioned this one. This one. This is here. I'm going to use this part for training. This part is for training. This part for this part for testing. This is the training. So you can mention this part is 70% data, this part for 30% data. So you consider one data set is 100%. This 100% is split out 70% for training, so 30% for testing. You can split out 80% for training, 20% for testing, or 60% for training, 40% for testing. You can split the your data set. But when you split, you need to apply some of the in the splitting. You need to apply some of the sampling method. You can use the random sampling, stratified sampling, and cluster sampling, and so like this sampling method you can use to you can take the sample from this one. So when we split like this, but when you split like this, you don't split from starting to end for training, remaining part for testing. You don't split. So randomly take the sample. You take the sample. So it's for this one, randomly take the data for training, randomly select the data for testing. So like this way is split out. So now we are going to split the data. Here if you see here, just I mentioned I need to just I'm going to split using that train underscore test underscore split method. Just I import that train underscore test and underscore test split is from sklearn model selection. So after import that, I'm going to create the four variable. So four variables say x underscore train, y sorry x underscore train, x underscore test, y underscore train, y underscore test called yeah, sorry, train underscore test underscore split. Just I passed five parameter I passed here. One is x. So this x and y represent the data set. Here we have mentioned the x and here we have the y. So the x y represent the data set. Just and then I here this parameter represent the test underscore test size. This is a test size 0.3. So 30 percentage for testing, remaining part is going for training. So next is a random underscore state. So this represent whenever you want to load the same, whenever you load the same data, you will get the same result. For the purpose, you can use the random underscore state equal to 7. So you can mention any value here. Here you can mention any value here, like that 32 or 49. So any value you can mention here. This is the purpose of this one. Just you are say, split the data set, you train your model. After training you have fit the model. Okay, so all accuracy is good, you feel that accuracy is good, you want to load your data set in any time, you want the same result. For that purpose you can use that random underscore state. Okay, now I'm going to explain this. What is this variable? This is represent stratified sampling. Stratified sampling is represent you. So stratified sampling, you already know that the stratified sampling. The population is considered the two sub sampling. From the sub sampling, it's going to randomly select the training and the testing. So because here we have three category. In this three category, randomly select from the three category for training randomly selected. So because when we split the training, one category is high, one category is low. Like this don't happen. So that's why you choose that the equal part. You need to choose the equal part, or you need to choose that randomly. That's for that purpose you can use the stratify equal to y. This is represent stratified sampling method. So just I'm going to run this one by one. I'm going to run this one. Okay, our data set, our training data set, testing data set ready now. So I'm going to create the one model. So here I'm going to create, I said that already I said that how k nearest neighbor is working. Now I'm going to import the k neighbor classified from sklearn. So just I imported. I'm going to create the model for k neighbor classifier. Just like knn equal to k neighbor classifier. Here I just choose the k neighbor equal to 4. Here this value we need to select the k equal 3, k equal 4, k equal 5, any value you can choose. But the finally you need to optimize values. But the later I will tell you which value, how to choose that correct k value. So now we just choose that k equal to 3. Okay, so after k equal to 3, just I'm going to, now our model is created. Now I'm going to create, sorry, now I'm going to train this model. So just I fit this model on this training data set, x underscore train and y underscore train. Just I fit this model on this train. So now I just train. Now I'm going to use this model for predicting for testing data. So if you see here, just a knn dot predict. So here just pass this testing data here for prediction purpose. I just pass the testing data here. This test our models predicted what is this what is the flower information. So if you see after prediction is happened, this I display here. Let's see display here what is happened. So if you see 2211, what is this? So here is so 30% data in the testing file. So in this case when we test, I predicted something 2211. What is mean here? So what is the two? So here see 0 Sedosa versicolor Virginica. So first two flower information is Virginica, next is a versicolor Virginica Sedosa. See it's like this is all the flower is predicted. We already have true label for this data x underscore. We already have the true label for x underscore tested, that is the y underscore tested. Just if we display the if we print the y underscore test, easily we can compare how our model is performed. So if you see, oh okay, this model, if we when we compare the true label with the prediction label to write, see here the three labels for three. Oh, here's correctly is predicted, but here see one, see this two. So I think so wrongly is predicted. So if you see two, this one. Okay, so if you see our true labels true two, but here true labels is our prediction labels one. So our model is here wrongly predicted. So like this way, when we compare how our model is predicted, say like this. Okay, so if you compare like this way, you will see you will get the sum of the percentage. So that is the score. That is x underscore test, comma y underscore test. If you see how our model is performed, so our prediction when you compare, our prediction accuracy is 97% is accurately predicted. So our model is performed well. So we can say if our model is performed well. So the less number of predictions only wrong. So the most of the 97% is predicted correctly, right? So we feel that our model is working well. So that's why we can use this model for predict the new information. So I have the new information. So x1, x2. So just a revision.
This conference will now be recorded.
Okay, see, we have our model is performed well. So if that our model is performed well, we can use using this model. We can predict the new flower information. I know two new flower information, but I don't know this is a sedosa or vesicular or virginica. This is also. So I'm going to pass this two flower information to our model. Just I pass here. I want two flower information. Just pass here. Its prediction is up. Oh, so two flower information. Uh, so this is same. When I pass this two flower information our model, it predicts two. So what does it mean here? The two flower in these two flower information represent the Virginica. Finally, we say that. So finally, we have some one confusion. How to believe this model accuracy? How to believe this one? How our model is how our model is worked well. We need to finalize. So it's correct or wrong. We need to predict. But before we finalize one, we need to some evaluate. We need to evaluate our model, right? So there are a lot of evaluation methods are here. So using the evaluation method, we are going to evaluate our model, how well our model is working. So that's why now I'm going to first method is I'm going to use the cross validation. Using the cross validation, I'm going to uh, I'm going to validate the model. So before I explain the how the before I explain the code of the cross validation, I little bit I'm going to explain how theory of the cross validation. So let me explain what is the cross validation. Okay, you have a data set, right? This data set we need to split the k fold. So what does it mean? You have a data set. Just I just use split over a data set like k fold. I'm going to split the data set like this one. This is the one part. This is just I'm going to split this one. How many parts? One, two, three, four, five, 6, 7, and 8, 9. If you see, if we take the 10 fold, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So finally we have 10 fold, right? So, oh, we got like this way we are going to, oh my god. Tenfold we are going to we need to loop the 10 times. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to repeat this process 10 times. So this is the cross validation. Okay, this is a cross validation. Now if you see, you take this one. In this cross validation, yeah, we call the 10-fold tenfold cross validation. So tenfold cross validation. That's why. So first, the last one I'm taking the consider the last fold for testing. These all is for training. The all fold for training. Last one fold for testing. So what is the accuracy for this one? Take this something. So 90. This is we call U1. Just integrating U. So U1. Next time for the second round, you consider this is for testing data, all for remaining all fold for training data. So what is the accuracy for this one? Something is 91. So next round, this is for testing data, validate, we are going to validate. So all is for the training. So this is for what is accuracy for this one. So something 90. Next time it's this code is going for testing, all for remaining all for training. So for this, what is accuracy? Something is 87. So next time, so what is this is for this code for testing, remaining all for training. So what is accuracy? 90. Next time, this is for testing, this code for testing, remaining all for training. So like this way, we are calculating one by one for tenfold. If you split the tenfold, you need to repeat the process 10 times. So if you split the eightfold, you need the process iterate 8 times. Like this way, one by one, you calculate the accuracy. After calculating the accuracy for one iteration, you need to take the average for all the result. You take the average for. If you take that, you like first is consider E1, E2, U2, E3. So you consider like this way. Finally, you take that E1 plus U2 plus E3. Like this, E10 divided by 10. You will get the average value. That is the cross validation accuracy. This accuracy is going to compare with our testing accuracy. So, like this way, the k-fold cross validation is working. So now we are going to implement this step in Python. Okay, so I think you all understand how the k-fold cross validation is working. So here, just I imported the model selection. Next, I imported the cross validation score, and then I'm going to create the instance for k-fold. You see here, just a k-fold equal to k-fold equal to model selection dot k-fold. Here, how many split you want? Yeah, just I represent the how many splits the tenfold, and then here just a random state is selected. So next, I'm going to create the classifier. This classifier I'm going I using this classifier I'm going to apply in k-fold cross validation. So here I just create the model for k neighbor classifier. Just I and then I just choose the scoring method. Here I just use the accuracy method. So next is the model selection dot cross validation. That this is represent that this process, the cross validation score. The process represent this process. So this process represent here this cross validation score. Just I pass the model here, and then I pass the input and output. Here how many fold we want. See here I just pass that here I split out the how many folds we want. Here we represent this. Here we just pass here what is the scoring. After scoring, you can get the result one by one. So you want to see the if you want to if you want to see each what is accuracy for each fold, we can print out, we can print a result. Yeah, and finally you take the mean value for you calculate the average for 10 fold. So just if you calculate the 10 fold, so when in the first fold what is accuracy, so the second fold what is accuracy, 1 1 1. So finally see what is the accuracy is next to careful is when I do the cross validation, so 92% is cross validation. But when I compare this result with this result, so there are less difference, or it show the high value, but it show the less value. So we need to check that why it's less difference. But more or less the equal. That's why our models perform well. We can say more or less they been well. The cross validation result and our accuracy score is if more or less equal, we can say our model is perform well. We can say our model is perform well. So finally, and then before we finalize our model, have we choose the correct k value or not? We need to confirm that. So how to choose the k value? So that's things we are going to see how to choose the k value. So now I'm going to choose that k value. I'm going to increase the k value one by one. So that's why the k just here see this is the just I just import the number and the matplotlib. Just I have created one number array. that array is started from 1 to 10. So here I have chosen 1 to 11, but 1 to 11, the value is going to put 1 to 10. So it's created 1 to 10, and then what is that? We need to collect the training accuracy, testing accuracy into list. That is why just we created empty list. So here we have created the empty list. So two lists we have created for for storing the training accuracy, testing accuracy. Here we have we have choose the neighbor values. So for the neighbor values we are going to pass in the loop. It's calculated, then training accuracy, testing accuracy, it is going to store in back in the list. So that's why, so for I k in the so for I comma I k in enumerate the this we have created the for loop, and then we have created the neighbors here. So we are fitting this this model on the training, and what is the training accuracy, what is the testing accuracy, we got it. So now we are going to we are going to plot this value in the two dimension. We see what is the title, what is the plot. So when you have the neighbors, what is the training accuracy? When you have the number of neighbors, what is that testing accuracy? We have here testing, we are testing here the created the legend value, and what is the x-axis label, what is the y-axis label. You see, that's after choosing here, you will see we need to choose the k value using, we need to choose a k value based on the two concept is over fitting, under fitting. When you train, when you train, what is when you train, the accuracy level is high. Using this model for testing, the accuracy is low, this is called overfitting. When we train, the model is accuracy low. um, when we when we test the model, its accuracy level is high. This sorry, first when you have the train, the model accuracy high. When we test the model, the accuracy is low. Accuracy is low, the underfitting. um, Sorry, when we train the model, you got the high accuracy. When we test the model, you got the low accuracy. This is a overfitting. When we train the model, we will get the low accuracy. Testing model, the high accuracy, that is the underfitting. So now using these two concepts, we are going to select the k value. If you see here, first I have to choose the k value here. So this is a training accuracy high, but if you see here, testing accuracy low, this is the overfitting, right? So that's why we need to choose that another k value. If you see here, this is a high, this is a low, but I think so something we need to base the k value here. See, this is not, but in the when we train so low, if you see here, this is the less variance. But when you compare here, you can say this something is, so we can finally choose this one, k equal to 3, k equal to 3, because we show the less varies. But if you see here, show the high bias. So that's why we need to choose, we can choose this one. But we can choose the, finally we can choose the k equal to 3, so we can finalize. All right, so we have learned how to choose the k value. Using this one, we can say finalize this one. So finally we can say that how to choose the k value. So after choosing the k value, we are going to classify, we are going to see that another accuracy model. We are going to calculate the our model accuracy. See here, I have used the accuracy score, and then here I have imported the confusion matrix. here I have about the classification report. So when you have the neighbor equal to 3, but and then create a model using the I'm going to create a model using the maybe I have neighbor equal to 3. So I just have to fit this model on the training data. What is the testing accuracy? So just I print out the what is the testing result. This one, what is that confusion matrix? Using this confusion matrix, when we have in Sedusa, we have 15 flower information, but our model as 15 is correctly predicted. The Virginica versicolor, sunflower is a versicolor. The model is predicted correctly. So 15 flowers correctly predicted. Finally, the Virginica. So in the Virginica, so 14 flowers is correctly predicted. One label is wrongly predicted. So in this confused matrix, we have seen that how our model is predicted the true level. So we are going to see the what is the precision, what is recall, what is F1 score. We are going to see. So the precision. What is precision? So what is the precision? How the precision is calculated? How the recall is calculated? How the F1 score is calculated? We will see that how it's all these values calculated. If we get the if we can finalize using that F1 score, but if we get any low value in this precision or recall, will our F1 score is going to low. So that's why if we get any low value in this anyone, if we get any low value in this anyone, we will try to trade off these two values. So you try to trade off these two value. You want to increase the F1 score. Right, okay, so now I'm going to show that just I'm going to show you how the precision is calculated, how the recall is calculated. So you see that the precision is our positive predictive value. Using this precision, how we need to we can calculate the proportion of the predictive true level. Predictive true level. If you see, I'm going to say the confusion matrix. I'm going to show the confusion matrix. In this confusion matrix, see this I have the true level, so predictor level. This I'm going to say the predictor predicted label. This is a true, sorry, negative, positive. See here, negative. This is positive. This is the predictive label. This is an actual label. So we can say and take this one. Okay. So true is a here we can say this is a in this one true negative. This is false negative. True positive. Here we can say false you can say that the false so false negative here is the true negative false positive the false positive so true positive. Now we are going to see the precision. Then the precision tell us the proportion of uh, proposed now predictive true positive. That's why we can say it's going to calculate this one, this one is using this one. We are going to calculate. So here is a formula. You see how it's TB by TB divided by TB plus false positive. If we take this one, the precision TB divided by TB plus false. This is the precision. And recall tell us this is a recall. You see here, I will show that what is the recall. Let's say the recall. So true positive divided by true positive plus false negative. So we said so this is recall. We are calculating the recall. This this portion. This portion is a recall. So true positive. This tells us the proportion of actual true positive. We are going to calculate the proportion of actual true positive. This the proportion of predictive true positive. So that's why so, so this is like this. So using the this is the confusion method. We can calculate that this value is this. So from this confusion matrix, we are calculate that this values. This is like this. The confusion matrix already is displayed here. The confusion matrix is already displayed here. So from these labels, the precision is recall is calculated like this. The precision recall is calculated. This is the confusion matrix. So okay, already we have explained what is the confusion matrix, how the precision is calculated, how recall is calculated. So now I'm going to explain how phone score is calculated. Now I'm going to say that to see I'm going to show that how the phone score is calculated. You see here, okay, there is we don't have any phone score calculation, so that's why we are going to see F1 score. This is F1 score. So 2 dB divided by 2 dB plus Fe plus F1. So if you see here, using this one, F1 score is uh, F1 score is calculated. So that's why we are going to see this is a F1 score. And you can, if you see, as you can see, uh, for each category, precision recall is calculated. Precision recall is calculated. Precision recall reference score is calculated. For each category, precision recall is calculated. So that's why if you get the raw result in any one category, you try to trade off. But in our model, in our problem here, the all result is Y. That's why finally we can say our the performance of our model is good. Okay, so you have developed we have developed the good model. So you see in any new Kolkata. Right. Thank you.